Hello and welcome back to the next week Alteryx weekly challenge. This is number 15. So this one is based on the same data set actually as the last one. So it's based on the warehouse distribution, if you remember from the last one. And this is where we now want to calculate the total shipped miles per item. So the products are available from 3 different warehouses this time. We only had one. I did wonder why we had the one in the last one. It was called main, but it's because obviously they were planning on having a second challenge based around this data, and they've increased the data. I'll show you in a minute. The objective is to find total distance travelled in a straight line miles for each item based on the shipping from the closest warehouse. So if you remember from last time, this is the original data that we had by store, and that's why the long lats were in there. So we've got the information here. Then we have this table here, which actually assigned is now placed in here. So we've got the numbers that we created last time and now been put in here, so we can basically tell how many items are going where. And then finally we've got the warehouse and the long latitude for that as well. So that's fairly straightforward in that we need to create distance. So here you create distance using the spatial tools. So first of all, we need to turn the long lats into points, spatial objects, or I think they call them centroids, and then measure the distance between the two. So let's start with this. So we've got each one of these has got a centroid, so we can just basically bring that in. I'll make this a bit bigger. Bring that in against the first input. It already populates the longitude, latitude, and then we can run that. And what that does gives us this tool here, which allows us to give a point for each of these stores. Okay, so that's that. We then have all of these items. So I think we'll come back to that and map that in later. We want to look at how do we work out what is the nearest warehouse to each of the stores here. So I'm thinking we need to create another centroid or spatial object, and again it populated the long lat, so if we just bring that in, we have this point here. So but we need to turn this into, I think if we join or append this into that data, we're going to end up with 3 rows for each store. And I'm actually thinking we want to have it all on the same row so that we can compare the distances and see which is the nearest for each store against the nearest warehouse. So I think if we do a transform and do a cross tab, then we can simply take the information here. So we want the centroid is the value that we want in the columns, and we can use the warehouse as a header, and we'll take the first. You have to fill this section in, well, it doesn't like it. So what we now have is a column for each of those warehouses and a point for the map, so it can work out where it is. So if we bring that in, there's only one row, so we can just append that one row to the original data, right? So we've got the centroid and then these, so that should give us, you can see the original centroid, which is the store location, and then the main. So what we need to do is work out the distances from each of these points. So in the spatial there is a distance calculator, and we can do, let's already pick the first one, centroid to main. We can then return, so output distance, return a distance. So when I port in, inside a polygon, this should create a line, I think. So we want a line, and then we don't need to know the direction. It doesn't ask for the direction, and then we want it in miles. We just go here. This total miles is the end result that we want. Okay, so let's run that and see what we get for the first one. So this is from store A to warehouse main is 622. So we can actually just repeat that, copy paste, and change it to be centroid to be second. Now, is it going to rename it? Maybe we'll run it, see what it does. Okay, we've got miles distance 2, so we can paste again, and then from third and run. So now have the miles distance for each one. Now we can see that for the first one, Euston, the first warehouse is the nearest. For the second one, so is the first one. But for the third one, which is Seattle, looks like the third warehouse is the nearest. So how do we work out which is the nearest? So I think we can do that by just looking at what's the if we just compare the first two between each other and see which is the shortest, and then compare whatever that is, whichever the shortest is, to the third one, and then let it pick the shortest one. So it's a if, my favourite if statements, you use them so often. So if miles distance, I guess we don't really care what this is going to be, just distance, isn't it? So we can create a column called distance. Actually, distance. And then, so if miles distance is less, doesn't matter, less than miles distance 2, then miles distance else miles distance 2. Okay, so that will just give us whichever we're going to give it an integer. No, it doesn't really matter. Double, fine. If miles is so whichever the shortest will then be put here. Yeah. Okay, so let's run that, and then we basically will have a distance which is picking up the shortest one. And then if we do repeat that, but we'll change it slightly, so we'll now say if distance is smaller than 3, then distance else distance miles 3. Okay, so that should give us the shortest of all. So let's just run that and see. It was on the third one we were expecting something different than on the. Yeah, so the third one has picked up the shortest distance one. So that works out quite nicely. Okay. Alright, so we now have the shortest distance. Now let's clean this up a little bit. We've got lots of columns now we don't actually need. So we don't need the long lats, we don't need the distance, we've just got the shortest distance anyway. We don't need the warehouse, we don't need the centroid. Do we need the state? I don't know if we need that either. We just got the store already. So, and we don't need the priority. That was all for the last one. So we've got the store and the distance. Okay, so then if we go back to the ask, the objective is to find the total distance travelled straight line miles for each item based on being shipped from the closest warehouse. Okay, so that means that we then have to take this. Oh, let's run it. I haven't got any data in there. Take this. So we've got the store and the distance, right? So we need to join it now with the original data. So we take a join. I don't suppose it matters which way round we do it. And then we bring in this. We don't need the store twice, but we'll have the distance and then we'll have the item. And then we don't need the required, we just need the assigned, I believe. So let's run that. Now that will give us, oh, didn't actually join it. We want to join it on the store. Okay, run that again. So now we have for each item the number, and the reason I think we need the number is because I think we're looking at each individual item delivered or dispatched, not for each one. Well, we can summarize it and see what. So we want to sum the distance by item, because I suspect, let's just try that, we need to times the 2, because either we need to filter out one or which is there's some zeros in there, so obviously there's no miles dispatched for that. So if we summarize on the item, so group by, and then we want to sum the distance. So if we run that, okay, so we now have a number. So 1 is 10,803. Now in here, 1 is way more than that. It's 467. So I think we do need to times it by the number of items here. So if we put in a formula here and put in, and we can use the distance again. So it's simply distance times, we want to times it by the number of items. Okay, so that should, why is that giving us let's just run that and see what we get. Oh yes, that's right. So then we now have, has that worked? Doesn't seem to. Oh, it's the assigned, not the number of items. What a numpty. Okay, let's take that back. Assigned, so because that's what we want to do. So let's run that and see if that makes a difference. There we go, and we have 467764, which is 467764. So I think we can just tidy this up. Item, total miles, well, we can just change it here, item, and then total miles. It seemed to be one word. We run that. There we go. So we now have the same result for both. Let's just do same result for both. Great. All right. Thanks very much for watching, and I'll see you all next time. Bye.